I would want us to look at probability, specifically the binomial distribution model and the Poisson distribution model. These classes are coming right away from Nairobi, capital city, AfriSchool's offices. AfriSchool is one of the biggest online CPA trainers that we have in this country. So I'd like to take this opportunity, first of all, to make a humble request to each one of us, those ones who are online. Let's share this post. Let's call all our friends to come and watch this video with us. Let's share. Let's call all our friends to come and watch this video with us. It's binomial distribution and the Poisson distribution. Binomial distribution and the Poisson distribution. Binomial distribution and the Poisson distribution. And specifically, I'm going to do the question that was tested last semester. That is November 2019. November 2019, question number 1, boy. Question number 1, boy. Let's take a minute and do the sharing. That's a noble exercise because we have to create a big platform for AfriSchool to reach out to so many students who right now are holed up in their houses because of this COVID-19. We need to help. When you share, you are helping your friends. We are fighting this COVID-19 together. Let's share. Come to our today's session. These classes are coming right. I'm sharing, and I hope you people are also helping us to do that noble duty, calling all our friends to come and watch this video with us. It's about binomial distribution in probability, Poisson distribution. Our objective by the end of the class, every student should have understood how to compute binomial probabilities and how to compute Poisson probabilities. Okay, so I'm doing this question right away We are told here, part B, that's last semester's exam, November 2019, question number 1, boy. 6 consultants work for XYZ Limited. A consultant has a 20% chance of being absent from work in a given day. The company needs to establish the probability of more than 2 consultants being absent from work. They want us to compute the above probability of absence, assuming a binomial distribution, and then number 2, a Poisson distribution. Assuming a binomial distribution and a Poisson distribution. Now, ladies and gentlemen, I will start with this binomial distribution. So binomial distribution. So binomial, bi stands for what? For 2. So you must be having a chance of success and what we call a chance of failure. So chance of success is what we call P, which you must start by defining. The probability of having this person being absent, we've been told, is 20%. So then this will be 0.2. If that is the chance of being absent, then the chance of being present, which will be defined by Q, will be 1 minus this P. So it is 1 minus 0.2, which gives us 0.8. So what am I saying, ladies and gentlemen? What I'm saying is that anytime they give you a question of binomial, first of all, you have to start by defining your P and your Q, P and the Q. And the moment you do that, straight away now you'll be able to remember the model, the binomials model. So binomials model, we have probability of x being equal to x, being equal to n combinations x, n combinations x multiplied by p raised to x, q raised to n minus what? X. This is a very important model of calculating probabilities, a model of calculating probabilities. If I were you, I would underscore this. And of course, for you to get more exposure, even after we have done this question, I really recommend these RCM books, RCM revision kit for you, which you can get from any of these bookstores outside there, Savanis, etc. I recommend these for you, RCM. You can also come to RCM Stand Bank House and get this there, which will help you in terms of getting more questions of this binomial distribution. Now, ladies and gentlemen, here we are. They wanted us to calculate a binomial probability. I've already written the formula. Which binomial probability do they want me to calculate? The company needs to establish the probability of more than 2 consultants being absent from where? From work. And remember, the consultants are how many in number? They are 6. So then they want us to give them the probability of more than 2. More than 2. So more than 2 means what? Probability of x being equal to 3, 4, 5, or 6. So you calculate the probability of x being 3, probability of x being 4, probability of x being 5, probability of x being 6. If you feel that these are so many outcomes, then you can easily use the complementary rule. This will be equal to 1 minus probability of the outcomes which are not here. The ones which are not here out of the 6 is probability of having 0, 1, or 2. It will be easier for us to look for these 3 than looking for these 4, right? So in this case here, we have probability of x being equal to 0. I'm calculating the probability of each one of them. Then this will be equal to n. N is 6 consultants. So we have here 6 combinations 0. We have 0.2, which is p. I'm following this formula. 0.2 raised to x, which is 0. And then we have 0.8 raised to n minus x. That is 6 minus 0, which is 6. The 2 powers must always add up to this. The 2 powers must always add up to that. So remember, there is a multiplication in between there. And then I'll come and calculate probability of x being equal to 1. Probability of x being equal to 1. I'm following this. So we have here 6 combinations 1. Then we have 0.2 raised to 1, raised to x, that is. Then 0.8 this time around will be raised to 5 because the 2 must always add up to 1. Equals. So we have the last one, px equals to 2. So we have 6 combinations 2 times 0.2 raised to 2, 0.8 raised to 4, because the 2 must always add up to what here? The 2 must always add up to 6, like that. So please get your calculator and device. Calculate this. So your calculator, get the combinations, As we're doing that, I hope you great students of mine are able to share the post. You are able to share the post. So we have here, let me just magnify this calculator of mine for all of us to see. So ensure first of all it's on. We have here 6, I'm doing the first one, 6 combination 0. See here, 6 combination 0 times 0.2 raised to 0 times 0.8 raised to 6, which will end up giving us 0.2, 3 decimal places, 62, like that. And then we have the same down here, 6 combination. I can use these navigators, 6 combinations 1 raised to 0.2 raised to 1 this time around. And then we have this 8 raised to 5, like that, which gives me 0.066, 3 decimal places. Now, I should have also changed this one here. 6 combinations 1.2 raised to this is supposed to be 0.393. I can repeat it again. We are saying it is 6 combinations 1 times 0.2 raised to 1 times 0.8 raised to 5 equals 0.393. And then we have 6 combinations 2 times 0.2 raised to 2 times 0.8 raised to 4, which will give me 0.24, 0.246. Let me repeat again, 6 combinations 2 times 0.2 raised to 2 times 0.8 raised to what here? To 4. 0.8 raised to 4 equals, I'm getting 0.246. Now, ladies and gentlemen, after getting that straight away, I need the summation of the 3. The summation of the 3, which will be probability of x being equal to 0 or 1 or 2, will be equal to 0.262 plus 0.393 plus 0.246, which at the end of the day will give us 0.901, like that, 0.901. After I get that, remember what this examiner wanted me to do is to come and talk of 1 minus this consolidated, 0.901. So we have here 1 minus answer, which gives us 0.099, like that. So once I get this 0.099, that is it. That marks the end of Roman 1 of the question, And that really will have to mark the end of our today's lesson. It has been a pleasure having you around. Please don't forget our books. And don't forget to sign up for AfriSchool online classes, whose number you can see up there, 0700 220 221. Thank you very much. Have a good day.